Okay, so welcome back. We're going to keep going with quantitative and qualitative data, but break it down further. So into kind of subcategories. So our four subcategories are called nominal, ordinal, interval, and ratio. What we're going to see overall, just to kind of get an idea, is your nominal data is always qualitative. Okay, so nominal level of measurement is qualitative only. Data at this level are categorized using names, labels, qualities. We do not do mathematical computations at this level. So when I say computations, I mean like adding them up, finding averages, things like that. So I usually remember it as nominal, kind of almost has that word name right in it. So it reminds me that your nominal data pretty much is names for things, labels. So what are some examples of nominal data? We've actually seen a few up here already. It could be eye color or favorite color. Social Security numbers. That's nominal data because again, it's really like a name. It's how the system knows us, right? As a number, but it's our name sort of in the system. Another kind of nominal data that is similar to Social Security numbers where you think it may be quantitative, but it's not, would be like numbers on a sports jersey. So for instance, a basketball team, everybody has a number on their jersey, or a football team, baseball, etc. Those numbers on your jersey, that's actually nominal data, is qualitative, right? So that number represents the person. It's like a name. So if I say, hey, number 22, you know who the player that I'm referring to, right? I'm not going to go ahead and find the average of the numbers on the jerseys. It doesn't make sense. I suppose I could physically do it, right? I could add up numbers and divide, but it's not meaningful in any way. So your nominal data, mathematical calculations are not meaningful. So we're not going to do them at that level. The next step up is ordinal data. Now your ordinal could be qualitative or quantitative. So this one gets a little bit tricky. So it could be a qualitative set or a quantitative set. But the biggest thing here is that it has order or it can be ranked. So I remember because ordinal almost looks like the word order, right? You kind of see that same word there. So you can order things. But the differences between the data entries are not meaningful. So if you subtract the data entries, they're not necessarily meaningful. So for example, could be letter grades in class. All right. So letter grades like A, B, C, D, and F, right? Those definitely have order, right? We know A is higher than F, right? I think most people know that just kind of intuitively if you know the English alphabet. So letter grades, there's definitely order here. But subtraction doesn't really make sense, right? A minus B, B minus C, C minus D, D minus F. Yeah, I guess you could say, well, it's about 10 points, but when we're talking about letter grades, you have to go to the number form of a grade to actually get into more detail there. So this is really just ordinal level data. And because it's letters, A, B, C, D, and F, it actually is qualitative as well, right? So I know in our brains, you kind of think of like, oh, an A is a 90 or a 95, but an A is just an A, it's a letter. So we're not actually going to do any, again, real mathematical computations there. So something that is ranked. Or something else, I could say first place, second place, third place, fourth place, etc. Right? So I could maybe rank the fastest runners. You got first place, you got second place, you got third place. Now the thing here, again, differences. So from first to second place and second place to third place does not mean that you have a consistent subtraction there. So it doesn't mean that we can't find the difference between, okay, well, how fast was the best runner versus the second best runner? So yeah, I could calculate their speeds there, but that's not first, second, third. That's actually looking at the data of their speeds, right? Which is quantitative. So the idea of just first, second, third, fourth here is ordinal. I can rank it, but again, I'm not going to take the average of 1, 2, 3, 4. It doesn't give me anything. I'm not going to subtract 1 minus 2 minus 3. Then it doesn't really make sense here. Next, we have interval data. Now, your interval and your ratio, these both have to be quantitative. Ooh, let's fix that. There we go. So those both have to be quantitative data strictly. So ordinal is the only one that could be like either or. So your interval data is quantitative. It can be ordered. It has meaningful differences between the data entries, can be calculated. So basically you can do all the math stuff you want to do, right? You can find your averages, you can subtract, you can add, you can do pretty much whatever you want. Here's the difference. At the interval level, a 0 entry simply represents, sorry, let's just say a position, excuse me, a position on a scale. The entry is not an inherent 0. Let me give you an example. The example is temperature. Okay. So temperature, right? I'm gonna do Fahrenheit. So let's say I have negative 10 degrees Fahrenheit, I have 0 degrees Fahrenheit, I have 25 degrees Fahrenheit. Today it's pretty warm, 40 degrees Fahrenheit, maybe in the summer, 80 degrees Fahrenheit, and so on, right? So these are all different values of temperature, right? It could be different data points if I had a data set. And I do have a 0 here, but it's just a value. It's not inherent 0. So when I say inherent 0, I mean the value of 0 would mean that there's no temperature at all, right? That doesn't really make sense. We can have negative temperatures, we can have positive temperatures. So 0 is just a 0 here, just another temperature. It doesn't represent the idea of none. So an inherent 0 represents the idea of none or nothing. Okay. So 0 degrees Fahrenheit does not mean that there's no temperature, right? It doesn't, it's just a temperature, right? Doesn't make sense. Another one is time, right? So you could have the year 10 BC, you could have the year 0, you could have the year 2020, you could have the year 2021, etc., right? So this year 0 does not mean that there's no time. It just means that it's just year 0. So your interval data has their numbers. We can work with them, right? I could find the average temperature. I could find, I guess, the average year if I wanted to, if I was trying to look at, maybe some data more specifically around a couple of years or something like that. So I can do mathematical calculations, but the value 0 is just 0. It doesn't mean that there's none. In your ratio data, and I remember it because ratio has a 0 at the end, so it kind of reminds me that a 0 is an inherent 0. It's quantitative, it can be ordered, it has meaningful differences. We can do all sorts of calculations. So you can do any math calculations pretty much you want. And the 0 is an inherent 0. So again, it has the idea of nothing. Now you also can use the idea of ratios. So with ratio data, you can take the ratio of 2 data entries so that one data entry can be meaningfully expressed as a multiple of another. So that's another kind of deeper way to think about your ratio data as well. But you can also do, like I said, ratios. So it does make sense when you're thinking about it that way, right? So one example could be, height or weight. Okay. So if you think about the idea of weight, right? If you weigh 0 pounds, you have no weight, right? We don't really have negative weight, unless I guess maybe if we're talking about space, right? If you're floating, I don't know. But realistically, if you're 0 pounds, you really are 0. You weigh nothing, right? If your height is 0, then you have 0 height. It really means nothing. You have no height. So the 0 here is an inherent 0. So it really has a basic idea of that nothingness. And that's what you're looking for. So your ratio data and your interval data are very, very similar. So they're quantitative. You can do all sorts of math calculations with them. The only difference is you have, sorry guys, an inherent 0 with the ratio data. So 0 really means nothing for that final piece here. let's just do a few more examples. Okay, let's look at this last example. So we have a few different examples here, and we're going to decide, is the data nominal, ordinal, interval, or ratio? So if you need to get your definitions from the previous page to have with you, you go ahead and do that. It does take some practice to get used to the differences. So just keep practicing and reading through your examples. So the first one is, the data you have will be the top 5 US occupations with the most job growth projected for 2024. So ranked number 1 would be personal care aides, ranked number 2 would be registered nurses, ranked number 3 would be home health aides, ranked number 4, food preparation workers, and ranked number 5, retail salesperson. So remember, your nominal data is qualitative only. Your ordinal data could be qualitative or quantitative. And your interval and your ratio data are both always quantitative. So first thing I'm going to notice here is that I'm looking at different types of jobs. This is definitely qualitative data, right? It's not numbers, so it's not quantitative. It's definitely qualitative. So it's either nominal or ordinal. Remember, order is with ordinal, so you can put things in order, and these are ranked in order, right? The best one is number 1, second, number 2, 3, 4, and 5. So because I can rank this or put this in a specific order, my data here is ordinal. Now for the second example, we're looking at different movie genres. So we have action, adventure, comedy, drama, and horror. So again, this is definitely qualitative data for sure, right? It's not numbers. So it's either going to be nominal or ordinal. Now my movie genres are not in any particular order here. Like they're not ranked. Oh, this is our favorite movie genre. This is our second favorite. They're just different movie genres. So there's no ranking. They are nominal. They're just names of movie genres. Now for C, you see the New York City World Series victories, the years that they won the World Series. I didn't write all of them. So if you go to page 11 of your text, you'll see all of them there. I just did the first couple. So 1923, 1927, 1928, 1932, and so on. So I do see these are all numbers here. And it would make sense that we could subtract these and work with them, right? Because I could take 1927 minus 1923 and see that there was a 4-year gap between their next World Series win, right? So I could actually do calculations and differences here with these numbers. It makes sense. So this is quantitative data. So your quantitative data is either ordinal, interval, or ratio. Now, because I can actually do calculations, so I can actually do meaningful calculations, right? So it has to have meaning. It's going to be interval or ratio. So it's one of those two. So these are the ones that you can do calculations with, or meaningful calculations with. So think about the idea of years or time. And we mentioned this before. So time is actually interval data. You do have year 0, but we actually could have BC as well, so years before 0. So year 0 does not mean that there's no time, it's just another year. So this is interval data. And again, that's because years, like years, again, a little bit different because you can go backwards all the way back through time, right? So the year 0 doesn't mean no time, it's just another year. In D, I see the 2016 American League home run totals by team. And again, you can go to page 11. I only did the first 4 teams here. So we can see that in 2016, Baltimore had 254 home runs, Boston had 208 home runs, Chicago 168, Cleveland 185, and so on. So I'm looking at the number of home runs, right? So over here, I do see that I have quantitative data. Right? It does make sense to do calculations as well, right? I could subtract to see who had more home runs than the other. I could find the average number of home runs, so I can actually do meaningful calculations here. And the 0 actually is inherent, right? If you have 0 home runs, you really have no home runs. It means nothing here. So if the idea of 0 means nothing or none, then you have ratio data. With ratio data, you can also do ratios. So for instance, I could find the ratio of Boston to Chicago, or I could figure out, what's the multiplier for Chicago times what gives me Boston. So I could do multiplication there as well. So ratio makes sense. All right, some more examples. Phone numbers. So think about your phone number. I have my office phone number. Now, your phone number is really like a name, right, or a label. So I know it's numbers. I suppose you could find the average phone number, but it doesn't really make sense, right? That data is not meaningful. So sometimes we can do calculations, but it doesn't make sense. So if it doesn't make sense, then you probably have qualitative data. So your phone numbers are definitely qualitative. They represent a person, right? They kind of represent that person that you're calling. So this is actually nominal. Right. And think about phone numbers. If I subtract phone numbers, it doesn't really make sense either, right? So those calculations really don't make sense here. Okay. Ranking them in order doesn't make sense either. So if you think about different parts of the country have different area codes, it's not necessarily that they're ranked in order of best to worst or anything like that. So this is just nominal data. The final standings for the Pacific Division of the National Basketball Association, so the NBA, your final standings would be like who came in first, who came in second, who came in third, who came in fourth, and so on. So if you have ranks like this, that would be your ordinal data. So if we can put it in order, but it doesn't really make sense to do calculations, that's ordinal data. All right, body temperature of an athlete during an exercise session. Again, be careful with body temperatures. We're doing degrees Fahrenheit. So body temperatures, they're definitely numbers. We can definitely do calculations, right? We can find the change in body temperature. We can find averages. But temperature in general is interval. Okay, so it's quantitative, but it is interval. So that idea of a 0 Fahrenheit doesn't mean you have 0 heat, or doesn't mean you have a 0, nothing temperature, no temperature for 0. So it's interval data. And then heart rates of an athlete during an exercise session. So if you think about your beats per minute, that's quantitative. And this is actually ratio data, right? Because the idea of having 0 beats per minute means you have no beats. It really means there's nothing, right? You're not going to have negative beats per minute. That doesn't make sense. So if you have an idea of inherent 0, so 0 means nothing, you have a ratio data set. All right, and at the bottom here, you just have a little bit of a summary to help you hopefully keep all this straight. It does take some practice. So one thing that's good to start with is to decide if the data is qualitative or quantitative, because at least that will help you narrow down. So for your nominal data, you see that it's qualitative. It can be put into categories, but ordering doesn't make sense, subtracting doesn't make sense. And really, the idea of having multiples or an inherent 0 doesn't make sense. For your ordinal data, it could be qualitative or quantitative. We can use categories, we can use order here, but again, subtraction of data entries doesn't make sense. We could sometimes do it, but it's not meaningful, right? It may not be the same difference from first to second place, as second to third place, as third to fourth place. So it's not a meaningful subtraction. And again, you're not going to be doing a lot of calculations here. So you shouldn't be doing multipliers or things like that. For interval and ratio data, they're both quantitative. They can both be put into categories. They could both be put into order. They can definitely both have subtraction and calculations and things. With interval data, again, you don't have an inherent 0. That means nothing, okay? And then you also, multiples or multipliers don't always make sense there either. So that's same for your ratio data.